Okay, let's unpack this. Today on the deep dive, we're tackling a really fascinating and honestly super common challenge in the enterprise world. How do you truly scale GitOps for large organizations? Specifically, we're diving deep into how you give real autonomy to over 100 development teams using Argo CD. And this is the tricky part, doing it all while keeping everything secure, efficient, and well governed. The stuff we're looking at today gives some comprehensive insights into the architecture, the strategies, and yeah, the best practices you absolutely need. So whether you're prepping for a big meeting, trying to get up to speed on enterprise GitOps, or maybe you're just really curious about how big tech solves these kinds of problems, well, this deep dive is definitely for you.
Yeah, and what's truly fascinating here, I think, is that managing deployments for that many teams isn't just about the tools. I mean, the tools are important, obviously, but it's really about the people, the processes you put in place, and critically, a robust, scalable architecture underneath it all. The core idea we'll be digging into is how a multi-tenant Argo CD setup is, well, pretty much designed specifically to handle this level of scale and complexity. It offers a powerful way to get that centralized governance without, crushing the agility teams need.
That's a great way to frame it. So when we talk about scaling Argo CD to that organizational size, hundreds of teams, where do we even start? What's the fundamental installation approach? The one that lets you do multi-tenancy right from the beginning so you don't end up in chaos later.
Right, that's the absolute starting point. If you're looking at managing Argo CD at enterprise scale, you really must choose the multi-tenant installation model from day one. Don't even consider the standard one. See, when you're dealing with potentially hundreds of teams, a standard single-instance Argo CD just won't scale effectively from a governance perspective. It wasn't built for that. The multi-tenant installation, on the other hand, is specifically designed to serve lots of different developer teams. It comes with built-in RBAC role-based access control and isolation mechanisms right out of the box. And that's fundamentally different from a core installation, which usually grants much broader permissions by default. So the immediate question this multi-tenant model answers is, how do you really isolate teams? So Team A can't mess with Team B's stuff, even by accident. And that's where application projects come in. They're absolutely the cornerstone of multi-tenancy in Argo CD. They aren't just folders, they're your main isolation boundary.
Okay, so multi-tenant install first. Got it. And these application projects are the key mechanism.
Exactly. In summary, for anyone facing this, multi-tenant Argo CD is built to support tons of teams because it has that essential RBAC and isolation baked in. And application projects, they're the bedrock. They make it work.
Okay, that distinction is super important. Application projects aren't just for organizing. They're fundamental security and operational boundaries. Could you break that down a bit more? What exactly can they control? Why are they so powerful?
Absolutely. Think of an application project like a dedicated secure workspace. It's built just for one team, or maybe a group of related applications. And within this workspace, you set very specific non-negotiable rules. First, you've got resource boundaries. This means you control exactly which Git repositories a team is allowed to deploy from. You don't want someone accidentally pointing to the wrong repo and deploying something unexpected, right?
Oh.
This prevents that. Only approved repos.
Okay, makes sense.
Yeah.
Limit the source.
Then there are destination controls. This lets you specify the exact target clusters and even the specific namespaces where that project's apps can go. So no more, oops, I deployed the dev app to prod scenarios. Very important.
It definitely avoids nightmares.
Third is the RBAC integration. This is powerful because you can map your existing company roles, maybe from Active Directory or Okta, directly to Argo CD permissions within that specific project. So developers might get sync rights, release managers get approval rights, all based on roles they already have.
So it leverages existing identity structures.
Nice. And finally, resource whitelisting. This lets you define exactly which Kubernetes resource types teams can manage. Maybe they can manage deployments and services, but definitely not cluster roles or CRDs, for example. It's like giving each team their own toolkit, but they only get the specific tools they're approved to use, nothing dangerous.
Like a safe sandbox. I like that workshop analogy. Freedom, but within very clear walls.
Okay, but here's where it gets really interesting for me, operationally speaking. If you've got 100 teams, 100, how on earth do you manage user access? I mean, without needing an army of admins, just creating accounts and tweaking permissions constantly, that sounds like a full-time job in itself.
You've absolutely nailed a core operational pain point for any large org, manual user management at that scale. It's not just inefficient, it's impossible, completely unsustainable. And that's precisely why Argo CD's built-in single sign-on SSO capabilities are so critical. It's designed to hook right into your existing company identity systems.
Ah, okay. So it doesn't try to reinvent the wheel for identity. Exactly. When you're onboarding dozens of teams, maybe monthly or monthly, authentication has to be automated. Argo CD gives you basically two main ways to do this SSO integration. First, you can use the bundled DEX OIDC provider. Think of DEX as like an identity middleman or translator. It supports different protocols your company might use internally, LDAP, SAML, or OIDC itself. OIDC is OpenID Connect, pretty standard for modern SSO. DEX is super flexible for mapping users and groups.
Okay, so DEX is like a universal adapter.
Pretty much. The second method is direct OIDC integration. This is simpler if your identity provider already speaks OIDC, which many modern ones do think. Okta, Google Identity, Azure AD, Auth0. You just point Argo CD directly at your provider. It leverages the identity management you already have.
And setting this up, is it complex?
The configuration itself usually happens in Argo CD's main settings, often in a Kubernetes feg map. It holds configuration data. You put in your identity provider's details, client IDs, secrets, that kind of thing. You can even set rules, like maybe only allowing logins for users who are members of a specific GitHub organization or team. So you're not managing individual users in Argo CD at all. Your corporate directory is the source of truth. It streamlines everything massively.
Right. So basically, SSO is non-negotiable for scale. It automates the whole user access piece.
Absolutely. It leverages your existing IDP, simplifies control, lifecycle management. Yeah, it's essential.
Okay, awesome. So we've got teams isolated in their application project, sandboxes. Users are logging in seamlessly via SSO. That handles a lot of the governance and access stuff. But what about just raw performance? Can one Argo CD controller instance really handle the reconciliation load for hundreds of teams, maybe thousands of applications across many clusters? That feels like a recipe for a bottleneck.
You're spot on. That's the next major scaling challenge: performance and throughput. As the number of applications, managed clusters, and Git repos grows, yeah, that single Argo CD application controller can definitely become a bottleneck. It's doing a lot of work comparing Git state to cluster state. And that's exactly why cluster sharding exists. It's not just a nice feature. It's really an essential architectural pattern for large deployments.
Sharding, like with databases, splitting the work.
Exactly like that. Sharding lets you distribute the workload across multiple replicas of the controller. So instead of one controller trying to juggle everything, you have several. And each one is responsible for managing only a subset of your Kubernetes clusters.
Okay, how does it decide which controller manages which cluster?
Good question. Argo CD offers a few algorithms. The default is hash-based. It uses the cluster's unique ID, its UUID, to assign it to a specific shard. It's static. There's also manual sharding, where you explicitly assign clusters to specific shards, maybe for like super critical clusters you want on a dedicated controller instance.
Right, fine-grained control.
But for a dynamic environment with 100+ teams, the round-robin algorithm is usually the way to go. Highly recommended. It just dynamically spreads the clusters evenly across all available controller replicas. Much better load balancing, especially if you're adding or removing clusters often.
Big dealing cards, basically. Everyone gets a fair share.
Yeah, that's a good analogy. It keeps the load balanced. Implementing it is usually just setting an environment variable, like Argo CD controller Sharding algorithm, round robin. And newer Argo CD versions, since around 2.9, I think, have dynamic cluster distribution. It automatically rebalances clusters if you scale your controller replicas up or down. Super handy. Keeps things smooth without manual fiddling.
Ah, nice. Self-healing performance almost.
Pretty much. It avoids having a single point of failure just because one controller is overloaded.
Okay, sharding handles the performance bottleneck. Makes total sense. Now let's connect this back to security again. Even with application projects setting boundaries and sharding spreading the load, how do we make absolutely sure that one team's Argo CD setup can't accidentally or maybe even intentionally mess with another team's stuff or operate outside its allowed zone within a cluster? We need really strong, like Kubernetes level walls, right?
Exactly. And this brings us to namespace isolation. This is another crucial layer of defense for real multi-tenancy. You know, smaller traditional Argo CD setups often run with cluster-wide permissions. The Argo CD service account can basically do anything across the entire cluster. For an enterprise with many teams, it's just too risky. It completely breaks the isolation principle we need for multi-tenancy. Huge security hole.
So how do you lock it down?
The way you implement this is actually quite straightforward, but it's super important. Instead of using the standard Argo CD installation manifest, you use a specific one, usually called namespace-install.yaml. What this does differently is it creates much more restricted cluster roles for the Argo CD server and controller components. Remember, cluster roles grant permissions across the whole cluster. By using restricted ones, you're drastically limiting Argo CD's own power.
So Argo CD itself has fewer privileges.
Precisely. This ensures that the applications Argo CD manages can only touch resources within their specifically assigned namespaces, the ones defined in their application projects. It's like having separate mini Argo CD instances, each confined to its own little namespace jail, metaphorically speaking. They can't see or interact with other teams' namespaces at all. This gives you really robust tenant isolation. One team's mistake or malicious action stays completely contained within their own area.
So even if something goes wrong higher up, the blast radius is tiny.
Exactly. It's a critical security backstop.
That is a critical layer. Okay, so we've got project isolation, namespace isolation, smooth authentication via SSO, and performance scaling with sharding. How do we tie all these security aspects together? What does that complete multi-layered security model look like for managing who can do what across all these different teams and environments?
Right.
We need consistency, right?
Right. It really is about layering different controls. You need a multi-layered security model that integrates RBAC at various levels. It's not just one thing. First, you have Kubernetes RBAC. This is the base layer. It controls what the Argo CD service accounts themselves are allowed to do within the Kubernetes cluster. Can Argo CD create deployments? Can it read secrets? That's defined here. And we just talked about restricting this with namespace install.
Okay, controlling Argo CD itself.
Second, there's Argo CD's own internal RBAC. This controls what authenticated users can do within the Argo CD application. Can they hit the sync button? Can they create new application projects? Can they view logs? It's about human actions on Argo CD.
Right, user permissions within the tool.
And then third, as we discussed earlier, you have the project-level controls. These are the highly specific, granular permissions defined within each application project. Team A can sync these apps to this namespace, but only read those apps in that namespace. Super granular.
Layer upon layer. Makes sense.
And when you apply this in an enterprise, you typically see common access patterns based on roles. For instance, your development teams. They usually get full access sync, modify, delete in their non-production environments.
Yeah.
Dev, staging, QA, whatever. But in production, usually read only. Look, but don't touch.
Standard practice, yeah.
Your platform teams, the folks managing the infrastructure, Kubernetes itself, maybe shared services, they'll likely need admin access, but maybe only for specific infrastructure applications managed by Argo CD. Security teams need broad visibility. So typically audit access across all projects and environments. They need to see everything that's happening for compliance, but they shouldn't have permissions to actually change anything.
Auditors, yeah.
And maybe executives or managers. They might just need dashboard visibility. See the health status, deployment frequency, that kind of thing, but zero operational permissions. Applying these layers diligently ensures everyone has just enough access to do their job, the principle of least privilege, and nothing more.
Perfect. That layered approach really clarifies how to manage access securely across diverse teams. Okay, great. So we've architected this really robust system. Multiple isolation layers, SSO, sharding, fine-grained RBAC. It sounds great on paper. Now, how do we actually keep this thing running smoothly day to day? And maybe more importantly, how do we know when it's time to scale it even further? What are the key operational things we need to think about when managing this beast, really, with 100+ teams?
Yeah, operational excellence is absolutely critical at this scale. It's not optional. It really boils down to a few key areas. First and foremost, monitoring and observability. You absolutely need centralized dashboards. Think application health views per team, per environment. You need to see sync statuses easily. Is anything out of sync? Why? Tracking resource utilization, CPU, and memory of your Argo CD components, especially the controllers, is vital for capacity planning. Tells you when to add more shards. And of course, automated security compliance reporting is usually a must-have for audits.
Visibility is key. Can't manage what you can't see.
Exactly. Second, your GitOps repository strategy needs to be super clear and well-defined. How you structure your Git repos matters. Typically, you'll have team-specific repos for their application manifests. That's their zone. Then maybe infrastructure repos managed by the platform team for shared stuff. Ingress controllers, monitoring agents, base cluster configs. You might have policy repos for things like OPA gatekeeper policies, managed perhaps by security or platform, and maybe template repositories that provide standardized starting points, like Helm chart templates to help teams follow best practices. Aligning repos with responsibilities is key.
Structure mirrors the organization.
Precisely. Third, scaling considerations. You need to watch specific metrics that signal growth pressure. Definitely monitor the application controller CPU and memory usage. That's your main indicator for needing more shards. Keep an eye on Git repository sync frequency and duration. Are controllers falling behind changes in Git? Check UI response times. Are developers complaining Argo CD is slow? That's a problem. And don't forget the basics. Track certificate expiration for your SSO integrations. An expired cert can take down logins for everyone. Sounds simple, but easily missed.
Ouch, yeah. Don't let that call.
No, you don't. Proactive monitoring here saves a lot of pain.
That's a solid set of operational points. Monitoring, Git structure, scaling metrics, and the basics like certs. Okay, so wrapping all this incredibly valuable information up, if some listening is building this out, maybe starting from scratch or trying to improve what they have, what are the absolute must-dos, the non-negotiables for both security hardening and just good, solid, ongoing operations? What are your top recommendations?
Okay, yeah, the non-negotiables. Let's break it down. For security hardening, first, network policies. Use Kubernetes network policies to lock down traffic to and from Argo CD components. Least privilege applies to networking too. Second, secrets management. Never, ever commit plain text secrets to Git. Use something like sealed secrets, HashiCorp Vault integration, or your cloud provider's secrets manager. Absolutely critical.
Number one rule of GitOps, right? No plain secrets.
You got it. Third, regular RBAC audits. Seriously, schedule these. Permissions creep happens. Regular review who has access to what and trim anything unnecessary. Enforce least privilege continuously. And fourth, enable audit logging. Make sure Argo CD is logging all significant actions. You need this for compliance and for investigating any incidents.
Okay, solid security points. What about operations?
For operational excellence. First, automate AppProject creation. When a new team comes on board, they shouldn't have to wait days for their GitOps setup. Automate the creation of their application project, maybe using something like a custom operator or a simple script. Make onboarding smooth. Second, use GitOps for Argo CD itself. Treat Argo CD's own configuration, its settings, its projects, its RBAC policies as code managed in Git. This makes your GitOps platform configuration auditable, versioned, and repeatable. Dogfooding, basically.
Practice what you preach. Nice.
Third, backup and disaster recovery testing. Regularly back up your Argo CD state, especially if you're not purely Git-driven for everything, and test your recovery process. What happens if the Argo CD cluster dies? You need a plan. And finally, documentation and self-service. Provide really clear docs and onboarding guides for your development teams. The more they can help themselves, the less burden on the platform team, allowing you to scale effectively. Empower your users.
Great list. Automate, GitOps yourself, DR, and empower users.
Yeah, I think that covers the essentials. At the end of the day, a well-architected multi-tenant Argo CD setup is really how you successfully scale GitOps across potentially hundreds of teams. It lets you keep that essential security, the governance you need, and operational efficiency all at the same time. But, and this is key, success really hinges on deeply understanding your own organization's specific needs. How much autonomy do teams need? What are your exact security requirements? What's your operational model? You need to configure Argo CD's multi-tenancy features to match your context. It's flexible, but you have to tailor it.
That's a perfect summary. It's not just about the tech, it's about fitting the tech to the organization's needs and structure. So as you, the listener, think about your own organization, whether you've got 10 teams or 100. How might these principles of isolation, authentication, sharding, and RBAC apply to your unique challenges? And maybe more importantly, what's the next small step you could take to make your GitOps journey even smoother based on what we discussed today? Something to think about.
That's all for this topic. Stay tuned for the next DevOps Cloud interview question.